So, to begin, we're going to do these top two problems. You do need a highlighter for this lesson, so I'd pull one out if you haven't already gotten one. So, here we go. We have 0. We have 0. What does this symbol mean? Yeah, what does the symbol mean? Greater than 3x minus 3 minus 6. I haven't done anything. I'm just writing down the problem. Here we go. What do we do first?
You add 6.
We combine our like terms.
Yeah.
What's minus 3 minus 6?
Negative 3.
Negative 9. It's okay. Alright, so what do I do next? Add 9. So I have 9 is greater than 3x. Then what do I do to finish the problem? Divide by 3. It's not negative, so we don't flip. Good. So do I like the way it looks? 3 is greater than x. No. I want x on the left side. And I will flip the sign as well to less than. So this would be my full answer. When I graph, will it be an open or closed dot?
Open.
Open, and I will shade to the left. Can I shade when it looks like 3 is greater than x? Can I shade when it looks like this? No, I'm not going to do it correctly. The x needs to be on the left in order for me to shade the correct direction. Our next one, we got 4x plus 1 minus 1 is greater than or equal to negative 8. What do we do to start? Combine my like terms. What's plus 1 minus 1?
0.
So I have 4x is greater than or equal to negative 8. What do I do next?
Divide by 4.
Divide by 4. Am I dividing by a negative?
No.
No, so I don't need to flip the sign.
No, you don't.
My x is on the left, so I'm good with the way that looks.
Yeah.
Am I going to have an open or a closed dot?
Close.
Shade what direction?
Right.
To the right. All right, so here we go. We're going to go into our notes. You're going to take out your highlighter. I made a mistake before we went on break. I did not finish the notes, and I printed them anyways, I guess. Appreciate it. So you're going to highlight angle bisectors. It's at the top of the page. We're going to go over perpendicular bisectors tomorrow. So highlight angle bisectors. That's all we're doing today. So I know there are these 3 things of what we're doing, but... So we're going to talk about bisector. Can someone with a raised hand tell me what a bisector is? Yeah, something that cuts something into 2. So what are we cutting into 2 if we have an angle bisector? An angle. Okay, so here is the fill in the blank that you have in the middle of the page. In section 1.5, you learned that an angle bisector is a ray that divides an angle into 2 congruent adjacent angles. You also know that the distance from a point to a line is the length of the perpendicular segment from the point to the line. And I will explain what that means. All right, so let's look at the picture I have drawn. You see highlighted distance from a point to a line. Yeah. Let's think about which one of these. I have my line on the left, my point on the right. Will the blue, green, or purple be the distance or represent the distance from the point to the line?
Green.
The green. What you don't know is that you just used today's property. What relationship or what do these 2 lines form together when they intersect?
Right angle.
They form a right angle. What is it called when 2 lines come together and form a right angle?
Perpendicular.
Perpendicular. So because they come together and form a right angle, this is the absolute shortest distance from the line to the point. Okay? So we're going to talk about that a little bit today. All right? You're going to take out your highlighter. you're going to highlight the bisector in your picture. The bisector will be the ray that cuts the outer angle in half. And you're going to label it angle bisector. What in the picture shows that my angle, my outer angle, BAC, was cut perfectly in half?
The right angles.
No, not the right angles.
The angles at the bottom.
The congruent marks. Okay, they're uneven. Does that matter in proving that they're congruent?
No.
No, it just shows that this angle is congruent to this angle. Okay, we're going to flip, and we're going to talk about a theorem. You'll use your highlighter more. We've got an angle bisector theorem. If a point lies on a bisector of an angle, so you're going to put a point, we're not highlighting anything yet, you're going to put a point at point D. So you're going to put a point at point D. All right, what does this green line on my screen represent? The bisector. So this is still my bisector. So here is the gist of this theorem. I have two congruent angles. That means the distance from the point on the bisector to the side of the ray, they're going to be congruent to each other. So what you're going to do is you're going to highlight these two lines right here. So the one I've highlighted in red. And you're going to mark that they will be congruent. 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 Because in this theorem it says if a point lies on the bisector of an angle, which it does, then it is equidistant. What does equidistant mean?
Equal distance.
Equal in distance. Perfect. From the two sides of the angle. So that means DC and DB will be congruent to each other. The same measure. So think of it like this. If your two angles are congruent, these two lines will be congruent. Okay, and the vice versa will also be true. You'll put a point down here for point D again. All right, we still have a bisector. All right, so put your point. Here's still my bisector. Because the distance from the ray to the point on the bisector is congruent, that makes the angles congruent as well. That makes AD bisect. So you want to mark that as well. So if the angles are congruent, that means these two lines will be congruent. If the lines are congruent, that means the angles are congruent. Okay, and we're actually going to do an activity with it in a little bit. All right, here we go. Using the angle bisector theorems. So letter A, we're trying to find the measure of angle ABC. What's my vertex of ABC? My vertex is a letter, so which letter?
B.
B. So I'm trying to find the measure of that whole angle of ABC, the one I've marked. All right? I know I have DA and DC. They're congruent. How do I know that they're congruent?
These are the blue, the marks at the top of it.
I just made those marks.
No, at the top. The 90 degrees.
That
The right
doesn't
angles.
tell you why.
Ah,
They're the same measure, 10 and 10. This shows it's the absolute distance from A to D. That's all that right angle tells you.
Oh.
Okay, so because the distance from the point on the bisector to the side of the angle are congruent, what can I tell about the two angles? They're also congruent, so that means this portion is 56. So to find the measure of angle ABC, what do you think I do?
Equal them.
Nope.
Add them together.
Add them together. 56 and 56, which will make 112. It's already done.
Oh wow, it's really coming down right there.
In letter B, we have two congruent angles. So if the angles are congruent, what do we know about these pieces? They're going to also be congruent. So if they're congruent, what can I do with them? Set them equal. All right, what's my smaller x?
2x.
2x, so I'm going to subtract that. So 2x equals 12, and x will equal 6. Did I answer the question?
No, we didn't. But I circled it anyway.
I gotta plug it back in. I want to find JM. Currently, JM is 4 times x, so 4.
24.
I'm getting there, bud. You don't have to yell up for me. 4 times 6 is 24, indeed. What can I do to check my answer?
Plug it in.
Plug 4 into the other one's side.
Yeah, plug it in the other side. 4.
6.
Plug 6. You're good.
Huh.
So 2 times 6 is 12, plus 12 is
24.
24. So we're good. Good way to check yourself is plugging it back into the other piece. All right, here we go. Flip. You're going to take your highlighter. So if you look on my page, mine says the blue line is an angle bisector. Yours does not say that. So go through and highlight all 4 of the angle bisectors. So there's 4 pictures. All right, so you're highlighting all 4 angle bisectors. All right, these are the 4 types of problems that you'll see. It says find the measure of angle 1 if the measure of angle 2 is 25. What do we know about angle bisectors?
They yeah.
They split an angle perfectly in half. What angle is split in half right now?
E.
Angle E. GEF would be the correct, or FEG. So if it's split in half, angle 2 is 25. What's the measure of angle 1? 25, because they're going to be congruent. So you're going to write off the side, measure of angle 1 equals 25. That's the answer. The next one, we have EGF. So outline EGF. So with one letter, what angle are we actually looking at?
G.
G. So we're looking at the whole angle of G. Is how many degrees?
48.
48. If the blue line bisects, meaning cuts it into 2 perfect pieces, how do I find the measure of angle 1? Divide by 2. What's 48 divided by 2? 24 and 24. So the measure of angle 1 is equal to 24. All right, we got 2 more, and they are the hardest.
This one you equal to 180.
Have I mentioned 180?
Here's equal.
No mention of 180, so put that somewhere else. Let's think about this. We got the measure of angle 1 is 1 plus 4x. What's the measure of angle 2? 3x plus 5. Do I know the measure of the outer angle? No, I don't. All right, I do know that the measure of angle 1 plus the measure of angle 2 will equal the measure of the whole angle, YWX. All right, but I don't know what YWX is. I do, however, know what relationship do angle 1 and angle 2 have. They're congruent. So what can I do if they're congruent? Set them equal. So 1 plus 4x will equal, what is it, 3x plus 5. What's my smaller x? 3x, so I'm going to move that guy. So 1 plus x equals 5. What do we do next? Subtract 1. X equals 4. Do I circle this answer? No. What do I need to do next? Plug it in. So the measure of angle 1 is equal to 1 plus 4 times x. 1 plus 4 times x. What's 4 times 4? I'm writing in red over here. What's 4 times 4? 16 plus 1 is?
17.
17. So I know the measure of angle 1 is 17 degrees. Technically, how much should the measure of angle 2 be? 17, but we can always check. What's 3 times 4? 12 plus 5 is? 17, so that one's good. So those two added together will tell me the measure of angle YWX. What's 17 and 17? 34.
Dang.
So that is the answer.
My thing is shaking.
You'll be okay. All right, so that's the answer to the first problem. We had set them equal. The second problem, we have Find the measure of UST, so that's our goal. Find the measure of UST. If the measure of angle 2 is 6x minus 1, and the measure of UST, UST is 10x plus 10. We don't add them.
Equal?
Well, let's look. Before we set angle 1 equal to angle 2, what would angle 1 be equal to?
6x minus 1.
It'd be 6x minus 1. Could I set 6x minus 1 equal to 6x minus 1? Can I?
No.
What will happen when I go to subtract 6x? I won't have any x's. What happens when I add 1? I'd have nothing. So this would not work. But here's what I do know. Look at what we did over here. The inner angle was 17 and 17. We added 17 and 17, and it equaled the outer angle. So yeah, we're going to do that. We're going to add our two inner angles. We're going to add the 6x minus 1. Add it to the other angle 1, so 6x minus 1. And they'll equal the outer angle, which will be 10x plus 10. So the two inner add up to equal the outer. Then we simplify. What's 6x and 6x make? 12x. Minus 1 minus 1. Minus 2 equals 10x plus 10. What's my smaller x? 10. So I'll have 2x minus 2 equals 10. I've got two more steps. What do I get x to equal? 6. Did I answer the question? No. I want to find the measure of UST. What does it currently measure?
6x.
Nope, says right there.
Oh, I thought you...
10x plus 10. So what do you think I can do? Plug it in. Yeah. 10 times 6 is 60. Plus 10 is 70. Ta-da!